in which matter rotates around the black hole, when astronomers discovered two black holes instead of one, and they're digesting the dust and gas caused by the greasy black hole. They were astonished. This finding is crucial because he showed that such black hole binary systems may be much more common than we previously thought. If paired black holes were so common, they may provide more opportunities to study the attractive forces rippling through space-time when black holes collide. Although it may be hundreds of millions of years before the pair of black holes we're talking about collide with each other. But by observing their behavior, scientists can better understand how many colliding double black hole systems there are in the universe. If the sun explodes, it was absolutely disastrous news for us. Although this is a blood-sucking term, but if a catastrophic event occurs on the sun, our solar system will be greatly affected. Scientist flaws. Such an event will eventually happen, but the specific way he unfolded and whether it was possible for us to somehow survive, it's still something that merits further investigation. The core of the sample is a hot environment filled with hydrogen atoms. These hydrogen atoms collide with each other at extremely high speeds and energies, triggers the so-called nuclear fusion process. In the process, hydrogen atoms combine to form C atoms. It releases an enormous amount of energy. So that's Einstein's equation of intelligence, 1 equals mc squared in practice. This energy is radiated out as light and heat, illuminated our solar system. Once the process begins, swarm of photons. These tiny photosites are jumping and flying in all directions. They play a key role in the process by which the sun shines. The sun's energy is transmitted through space as our world provides light and warmth, make our planet comfortable, to maintain the device and prevent atoms from escaping and causing chaos. The core of the sun is under tremendous pressure. This pressure is due to the tremendous weight of the sun. Its outer layers exert false pressure on the core. Despite this, the busy photon population in the core still struggles to escape. Due to the fact that the core is extremely lethal, this energy takes quite a long time to release. They bounce off inside the sun, absorbed by other particles, launch again, eventually reach the surface of the sun after a long time, swiftly into space, shine on us in the form of sunlight. When the sun reaches the end of its life, a series of major changes will take place. About 5 billion years later, when the sun said recently in the Qing dynasty, he will expand into a red giant, huge enough to swallow the inner planets, including Earth. After becoming a red giant, the sun will contract. Its outer layers are scattered into space, leaving a glowing core, forming beautiful planetary nebulae. At this point, the handsome core will begin to integrate heavier elements, like oxygen and carbon, but these reactions will not be as active level as before. Eventually, even the sea gas will be exhausted. The sun will become a deadly white dwarf, entering a stellar retirement. Scientists estimate that the sun still has about 78 billion years to go dark. But by then, humans may have traveled to distant novelties, even evolved into amazing space creatures. Our sun is not big enough. It cannot become a supernova or a black hole. These cosmic phenomena require more massive stars. Suppose the sun suddenly explodes. This is going to be a disaster without warning. A lot of energy is released during this time. The resulting shock wave takes about 8 minutes to arrive. The explosion will be spectacular. But it also means the end of the Earth and other internals. In addition to that, there will also be massive radiation outbursts. The sun will release a large number of charged particle tumors, including X-rays and gamma rays. These energetic particles concentrate in the atmosphere, cause serious damage, ionize the atmosphere, and generate a massive electromagnetic pulse. This can be lethal to electronic devices. In addition, the final explosion of the sun will not only destroy the Earth, it could also have devastating effects on the entire solar system. The massive release of energy would dislodge planets and other celestial bodies from their orbits, causing confusion and unpredictable consequences. Even the planets that survived the disaster could veer off course. Extraterrestrial stars like Jupiter and Saturn, although they have their own internal heat source, but the dying of the sun will make them extremely cold, revolutionize their environment. Considering the impact of a potential catastrophe on our solar system, one of the logical questions we face is whether humanity will survive. So in a nutshell, in the event of an extreme disaster, it's hard for us to survive. Almost everything will be destroyed, unless we find a way to hide in the shelter. But if we know in advance of the sun's dangerous plan and have time to prepare, then we might have a chance. That means we need to think about how to make our survival strategy work. Due to the fact that the Earth cannot withstand the effects of extreme solar activity, we must find a new home. Unfortunately, Mercury, the closest planet to the Sun in the solar system, Venus and Earth will not survive. Therefore, we may need to search for another solar system. There are planets like Earth, but if the Earth somehow survives, we don't think about how this happened. Only discuss the consequences. Our climate will become extreme as the sun explodes. The sharp increase in radiation and temperature will lead to a major greenhouse effect. The oceans evaporate to form thick clouds. Trapped heat. Don't let it escape into space. After that, if there is no warmth from the sun, the Earth will cool rapidly into a cold world. In this case, one possible survival strategy is to take refuge deep underground, where we won't be too affected by radiation and sudden temperature changes. As we dig deeper, the temperature will gradually rise. Therefore, there are appropriate tools and resources. Humans may be able to survive for years in underground bunkers without sunlight. However, we must also face the fact the sun is the center of the solar system. If there is no sun, the Earth and other planets could lose their stable orbits, float into space. Fortunately, the sun is still hanging steadily there. Offer us warmth and light. Make sure we can continue our cosmic adventure. Despite this, it's always interesting to discuss these extreme scenarios. He inspires us to imagine the possibilities of the future. In reality, our sun is more powerful than many other things in the universe. Relatively unremarkable. It is one of millions of similar yellow dwarfs. Despite this, we still love him because he gave us life. It's been theorized the sun may have a twin, an evil twin, Our sun and possible lost twin both originated from the same giant molecular cloud, also known as the Dark Nebula. It's filled with gas and dust, and these molecular clouds are where stars form. About 450 million years ago, an energy broadcast started the process by which the sun was born, bringing together gas and dust, formed a dense protostar. As time goes by, the temperature and pressure inside this young star have increased, eventually formed the sun we know as. However, not all matter became the sun. The remaining material starts to orbit the star at the heart, eventually formed planets including Earth. This is how the solar system travels. There is a theory that, born with our sun, there may be more than just one, but a group of stellar siblings, including a large twin of similar quality and characteristics. Scientists use statistical models to understand the birth process of stars. The discovery that many stars did not appear alone. It was born with at least 1.5 stars. This means that the sun may have had one or more half-stars. Sometimes significant others stay together. Formation of binary or multiple star systems. Sometimes they go their separate ways. This may also be the case with our sun. So if there is a lost twin, where is he now? Scientists are beginning to observe a pattern in Earth's history. That is, approximately every 27 million years, Earth would experience a mass extinction event. This periodic extinction phenomenon has attracted the attention of scientists because he seemed to suggest that there were cyclical external factors at work. Astronomer Richard Muller proposed a hypothesis. It is believed that there may be a celestial body, like a dwarf star, due to its low brightness. We can't observe it directly. This celestial object could be located about 1.5 light-years away from the sun. The orbit around the sun is huge. It takes about 27 million years to complete one orbital period. As this celestial body approaches the solar system, it will cause a series of chaos. In particular, it alters the orbits of comets in the Oort cloud or the Kobo-1 belt, causing these comets to crash towards Earth, trigger a mass extinction event. The hypothetical object was named Nemesis, named after the ancient Greek muse of retribution. Muller's theory is that there is a connection between the appearance of Nemesis and catastrophic events in the solar system. Perhaps because during the formation of the sun, almost all the dust and gas is absorbed by the sun, causing the twin to dim and be forced out of the solar system into uncharted space. Scientists have proposed a variety of hypotheses about Nemesis's mind, including that it might be a dwarf star, a red dwarf or a rampant remnant that has completely run out of fuel, maybe even a giant rogue planet. Although this hypothesis has attracted widespread attention online and in coverage, but recent studies have called into question the theory of this low recent mass extinction. Further investigation of the fossil record revealed that these catastrophic events can occur more randomly, rather than following a clear schedule. In addition, any celestial object moving in a similar orbit will exhibit extreme instability over long time scales. It is unlikely to last long enough to affect the Earth. Therefore, although the concept of Nemesis is still popular in some circles, but lack of direct evidence knowledge of its existence. Here's the thing. Even though Nemesis itself may not exist, This doesn't mean that the sun doesn't have possible twins. As previously discussed, most stars travel with at least 1.5 stars. Therefore, the possibility that the sun may also have one or more siblings remains. Some anomalies in the very high Oort cloud may suggest the existence of unknown celestial bodies outside the solar system. This region appears to be heavier than current solar system formation models predict. When scientists factor in a possible second sun in their calculations, these differences in weight anomalies were explained. It's like finding the missing piece in the puzzle. So there is indeed reason to believe that the sun once had a twin. But what is its fate? Where he is now is a mystery. Unfortunately, this star may be moving away from us, probably shortly after the sun was born. These cosmic brothers and sisters have only been together for a few million years. Then they went their separate ways. Now the lost brother of the sun may be located hundreds of light years away. He could be hiding anywhere in the galaxy. In theory, we have a chance to find him. But it's actually extremely difficult, because it requires us to screen out all the stars in the entire galaxy that are about the age of the sun. Even if we could make a list of these stars, it's almost impossible to determine which twin is really the sun. So the first twin may remain a mystery forever. And our sun will continue its lonely journey. This is a story full of sadness. But let's cheer up. If there really is another sun, our sun flag might not be what it is today. Even our planet may not exist. And that means there might not be life at all. So perhaps we should be grateful for the sacrifice of the sun. On the other hand, if there are two suns, our sunsets could be as spectacular as those of the Star Tattoo in Star Wars. To explore the possibility of extinguishing the sun, for example, if we took all the oceans on Earth, what will happen to even more water? The universe is a mysterious realm. Since ancient times, scientists have been exploring how space works. But for the existence of the sun, we never had a question. The sun is the center of our solar system. It's big and bright. Seems to last forever. In fact, the sun is just an ordinary giant star. Suksing is mainly composed of hydrogen, accounting for 75%. A small amount of C-grade and other heavy elements, by attractive force. But after about 5 billion years, the sun is approaching the end of its life. Then the Qing River within him will be exhausted, start to swell, become so big, so much so that you can't imagine that he will start swallowing all the neighboring planets. By then, we may regret being so close to him. The sun will remain a red giant for about 1 billion years. And he will start to contract, become a white dwarf. In the end, only a bright and colorful shape and mind are left. But there is no need to panic now. The sun is in the middle of its life cycle. About 450 billion years after its birth. It is expected to take the same long time. Fortunately, we live in a time when the sun is at its most stable. Huanyanji is not too worried now. So, what if the long-term passage through Qingdao water accelerates the life cycle of the sun? The first is to take a long time to concentrate all the water on Earth. Qingdao to the sun, We need a very, very large bucket. The bucket needs to have a capacity of about 135 million cubic kilometers. Its volume is equivalent to the distance from Washington to Chicago. If we could only use ordinary buckets, then it takes about 18 times 70 times 10 to put a bucket. Imagine that. If we really had so many buckets. It's time to try to extinguish the sun. It doesn't seem like a big deal to throw all this water at the sun. The sun may feel a little sad because of this. Even produced a tiny sun patch. It turns out, all the water on Earth is a drop in the bucket for the sun. People often underestimate the true size of the sun. It's actually big enough to hold more than 1.30 million Earths. So the sun doesn't go out or get colder because of our cities. He won't even notice what we're doing. But let's not give up easily. If we really want the sun to disappear for some reason, what will happen if there is enough water in Qingdao? The amount of water required is unimaginable. The amount of water we actually need will be a huge number with 27 zeros. So we can only say, now there's a lot of water. Let's try again to throw it towards the sun. Although it looks like a Steam 4 flag. But the sun didn't go out. Instead, he seemed to say thank you to us. It gets bigger and brighter. So what's going on here? You see, the sun doesn't actually shimmer like a flame in a campfire or a candle. When we pour water over such flames, water extinguishes a flame by absorbing the heat of the flame and cooling it to the point where it cannot sustain a combustion reaction. It also prevents the flame from coming into contact with oxygen. Basically interrupts the chemical reaction process. But the burning process of the sun is not such a reaction. In fact, the sun undergoes a reaction called fusion. It's the most intense in the universe. One of the most frenetic processes. A large number of clear atoms were compressed in the depths of the sun. By binding the dead clean atoms together, they transform into a bad atom and release energy. This process is more than we usually say. The burning of the sun is much more complex. The mutually exclusive forces between politicians require tremendous strength and energy to overcome. Compress them together in some way. Fortunately, the sun has the attractive force of space to accomplish this task. The sun makes up 99.8% of the mass of the solar system. Its weight, with this incredibly attractive force, push together countless green lotus seeds every second, every day. When these lotus seeds collide, they release energy. So unlike a normal flame, the sun doesn't need oxygen to burn. He needs hydrogen. We know. And water is HRO, which is hydrogen and oxygen. Therefore, in a certain sense, water is actually a fuel for the sun. Attempt to extinguish the sun with water. It's like putting out a fire with gasoline. Not only invalid, instead it makes it reverse. But here's the thing. The extra mass added by water would make the sun heavier, increasing the attractive force. This accelerates collisions between protons. This actually makes the sun stronger. Now he has started to devour us and other nearby planets. If we continue to add water, the sun may eventually collapse under its own weight. Become a black hole. Devour everything. But let's get back to reality. Because obviously this whole sun dumping thing was a mistake. A little sun patch might sound more rational. Return to the familiar calm state of the sun. But we seem to have forgotten the importance of water for life on Earth. Once the ocean disappears, huge numbers of fish and other marine life will lose their habitats. Deep-sea creatures cannot withstand such dramatic changes and pressures. Algae and coral will also wither. They're the key organisms responsible for producing 50 to 80% of the world's oxygen. It's just as bad on dry land. No more oceans. No clouds or rain, leaving forest fires everywhere. The animals had to flee their homes. There's almost nowhere to live. The earth turned into a giant desert. Although humans have lived in deserts for thousands of years, but surviving without water became nearly impossible. The oceans are not only absorbing huge amounts of carbon dioxide, it also absorbs heat from the sun and distribute that heat around the world, keeping the planet warm and livable. Once the ocean is lost, the surface temperature will rise rapidly to 250 degrees Fahrenheit, above about 121 degrees Celsius. And without the protection of clouds, we will be directly exposed to solar radiation. The melting iceberg could become humanity's last hope. But in extreme heat, they disappear quickly. It seems that adventure to try to put out the sun was stupid. But it reminds us of the forces in the universe and the fragile balance of nature. Thanks to Pluto's low attractive force, you can jump up to 7 meters. It's like jumping over a 2-story building. Have you ever wondered how high you can jump on different planets? Imagine dunking on the moon, or barely able to take off from Jupiter. Please continue to watch. See which celestial body will make you a super jumper. Which one will make it almost impossible for you to get off the ground? First, let's talk about the attractive force. Attractive force is the force that keeps us grounded. Attractive force attracts objects closer to each other. So when you put down an apple, he will land because of the attractive force of the earth. Attractive force depends on 2 things, quality and distance. The greater the mass of the object, the more attractive force. The closer you are to the object, the more attractive force you feel. For example, the Earth is very massive, so the attractive force is strong and the moon is less massive. So the attractive force is weak. That's why you can jump higher on the moon than on Earth. Now we understand the basic principle of attractive force. Let's see how it affects our ability to jump on different planets and moons. So let's start with Mars. Mars is our red neighbor. About 1/3 of the Earth's attractive force. This means that if you weighed 70 kilograms on Earth, on Mars you would only weigh about 23 kilograms. So how tall can you pick? On Earth, you can jump about 1/2 meter off the ground. On Mars, the attractive force is weaker. You can choose about 1.5 meters high. Mars's lower attractive force and atmospheric pressure will keep you in the air for slightly longer. It's like slow motion. Let's jump to the giant Jupiter. Jupiter is a behemoth in our solar system. The new attractive force is 2.5 times that of the Earth. This means that if you weighed 70 kilograms on Earth, on Jupiter you would feel as if you weighed 175 kilograms. Due to its attractive force, you might only be able to jump a few centimeters off the ground, about 0.17 meters. You can't actually stand on the surface of Jupiter because he's a gas giant. Its powerful, attractive force will make you feel like you want to carry a heavy backpack every step of the way. From attractive force to something a little easier. Let's see what it's like to jump on Neptune. The blue giant has an attractive force about 1.14 times that of Earth. If you weighed 70 kilograms on Earth, it would have weighed more than 80 kilograms on Neptune. Here you will jump about 0.39 meters lower than on Earth. Not much difference, but you will feel a little heavier. Neptune's powerful winds and icy atmosphere will make you feel like jumping in a frozen hurricane. Next, we come to our sister planet Venus. The attractive force of Venus is similar to that of Earth. It is about 0.9 times the size of the Earth, so if you weighed 70 kilograms on Earth, on Venus you would weigh about 63 kilograms. On the surface of Venus, you can jump a little higher than on Earth, about 0.49 meters. The thick atmosphere of Venus will make you feel as if you are moving in slow motion. Now let's head to the edge of the solar system. See how high you can jump on the dwarf planet Pluto. This small world has very weak attractive forces, only 1/12 of the Earth. So if you weighed 70 kilograms on Earth, on Pluto you would weigh only 6 kilograms. Due to Pluto's low attractive force, you can jump up to 7 meters. It's like jumping over a 2-story building. Low attractive force makes you feel very light. It's almost like flying. Next, let's head to Skynet's moon Miranda. See what can be done there. The attractive force of this satellite is extremely weak, only 1% of the Earth. So if you weighed 70 kilograms on Earth, on a Miranda it would also weigh less than 1 kilo. Here you can jump up to 57 meters. It's like jumping over a 15-story building. Miranda's stealth means you will descend slowly. It feels like I'm on a trampoline. Charmin moves, jumps. Don't worry about breaking your leg. Now we visit the moon of Mars, Phobos. It's an eye-opener. The attractive force of this small satellite is extremely low, weaker than Miranda. Its profits are about 1/700 of the Earth's. So if you weighed 70 kilos on Earth, there are only a few on Forbes. Here you can easily jump to a height of 700 meters. It's like going over a 230-story building. Forbes' attractive force is so weak. You need to be careful not to jump too high. Otherwise, you might jump yourself directly into space. And finally, let's see what happens if you try to jump on the Sun. The Sun, the giant star at the center of our solar system, has an attractive force about 28 times that of Earth. So if you weighed 70 kilos on Earth, it weighs nearly 2,000 kilograms in the Sun. Of course, the Sun is a glowing ball of gas and plasma, so I can't stand on it. Even if there is a strong attractive force on the surface of the solitary body, it will weigh you down. Not to mention jumping. So which planet would you like to try jumping on?